Welcome to today's session on the crucial topic of safety in AI, a cornerstone of responsible machine learning. Safety in AI refers to the measures and protocols put in place to ensure that AI systems operate reliably and do not cause harm to humans or society. As AI becomes more integrated into our daily lives, ensuring its safety is paramount to prevent accidents, misuse, and unintended consequences. AI safety involves designing, testing, and maintaining AI systems to function correctly under expected conditions and to handle unexpected situations gracefully. Safety considerations span from the initial development stages through deployment and ongoing monitoring, covering both the technical and ethical dimensions. Robustness. Ensuring AI systems can handle a wide range of inputs and conditions without failing. Reliability. Guaranteeing consistent performance over time and under varying conditions. Security. Protecting AI systems from malicious attacks and unauthorized access. Ethical use. Ensuring AI systems do not cause harm and adhere to societal norms and legal standards. Real-world examples of AI safety. Self-driving cars, such as those developed by Waymo and Tesla, must navigate complex environments safely. In March 2018, an Uber autonomous vehicle struck and killed a pedestrian in Arizona, highlighting the critical need for robust safety protocols. Companies are implementing extensive testing, real-time monitoring, and fail-safe mechanisms to improve the safety of autonomous vehicles. AI systems like IBM Watson for oncology assist doctors in diagnosing and treating cancer. However, incorrect recommendations due to data or algorithm errors can have serious consequences. Ensuring rigorous validation and real-time oversight by medical professionals are crucial for the safe deployment of AI in healthcare. Robots in manufacturing settings, such as those used by companies like Siemens and General Motors, must operate safely around human workers. Implementing safety protocols, such as emergency stop mechanisms and collision avoidance systems, helps prevent accidents. Challenges in ensuring AI safety are, numerous and complex. Let's start with the complexity of AI systems. AI systems, particularly those using deep learning, can be highly complex, making it difficult to predict all possible failure modes. For example, deep learning models for image recognition might misclassify objects under certain conditions, leading to safety risks in applications like autonomous vehicles. Another challenge is adversarial attacks. AI systems can be vulnerable to adversarial attacks, where small changes to input data cause incorrect outputs. Take this example. Hackers can manipulate traffic signs with stickers to fool self-driving cars into misinterpreting them, posing significant safety risks. And then there's data quality. The quality and diversity of training data are critical for the safe performance of AI systems. For instance, biased or incomplete data can lead to unsafe recommendations or actions, such as in predictive policing systems that disproportionately target minority communities. Mitigating safety risks in AI. Rigorous testing. Implementing extensive testing under various conditions to identify and mitigate potential failure modes. Example: Tesla conducts millions of miles of real-world testing for its autonomous driving software to identify and fix safety issues. Fail-safe mechanisms. Designing systems with fail-safe mechanisms to handle unexpected failures gracefully. Example: Robotic surgery systems have manual override capabilities to allow surgeons to take control in case of malfunction. Adversarial training. Using techniques like adversarial training to make AI models more robust against malicious attacks. Example: Training image recognition models with adversarial examples to improve their resilience against manipulated inputs. Human oversight. Ensuring human oversight and intervention capabilities to monitor and guide AI system operations. Example: AI systems in critical applications like aviation and nuclear power are designed to work alongside human operators who can intervene if needed. Regulatory and ethical considerations. Regulations. Adhering to regulatory frameworks and industry standards that mandate safety protocols and risk assessments. Example: the European Union's General Data Protection Regulation, or GDPR, includes provisions for the safe and ethical use of AI. Ethical standards, aligning AI system design and deployment with ethical guidelines to ensure they do not cause harm. Example, the IEE Global Initiative on Ethics of Autonomous and Intelligent Systems provides guidelines for the ethical design and deployment of AI technologies. Future directions, ongoing research and collaboration among stakeholders to continually improve AI safety. Example, initiatives like the Partnership on AI bring together industry, academia, and civil society to advance AI safety research and best practices. Conclusion. Recap. In summary, ensuring safety in AI involves addressing robustness, reliability, security, and ethical use throughout the AI lifecycle. Final thoughts. By prioritizing safety, we can harness the full potential of AI while minimizing risks and protecting society. Closing Daidian. Thank you for joining this session on AI safety. Stay tuned for more insights on responsible machine learning.